Let's predict the product of the reactions shown. We're going to start by treating the terminal alkyne with sodium amide, which is going to do an acid-base reaction to make an acetylide anion. So by removing that terminal proton, we end up with a molecule that has a negative charge on the terminal carbon, this sp hybridized carbon. This is going to be a good nucleophile, so if we redraw the alkyl halide that we're starting with, we can now do a substitution reaction where this electron pair is donated to the carbon here and at the same time pushes out the bromide anion. So Br- is relatively stable. It's a good leaving group, so we can do this substitution reaction. Now, one of the things you want to do here is number carbons to make sure as we draw the final product, we haven't made a mistake. So we'll number those 1, 2, and 3. We'll number these 4, 5, and 6, and we can stop there because all that's really important is for us to recognize that we're forming a new bond between the 3 and the 4 carbon. So let's draw that. We'll start by drawing the ring. This will be the carbon labeled as 1. The carbon labeled as 2 is the first carbon of the triple bond. The carbon labeled as 3 is the second. We're going to have a new bond to carbon 4. It goes up to carbon 5, down to carbon 6, and carbon 6 has the ring attached. Now let's apply that same numbering. We'll put the numbers in, 1, 2, 3. Here's our new carbon 4, 5, and 6. This bond here is the new bond that we formed. By numbering the carbons, we've ensured that we haven't made a mistake, and we've convinced ourselves that this lone pair represents the electrons. These 2 electrons are the 2 electrons in the new C3-C4 bond. Just if we wanted to be complete, we could also acknowledge that we've made Br- as our stable anion that left when the electrons added to carbon 4.